Hi guys, thank you for coming. Feel good about after lunch. My name is Vladimir. I'm working for Elkomsov, the company based in Moscow, Russia, with about 25 people working in the, not exactly the computer security, we're doing the computer forensics for over 20 years. For last 5 or 6 years, we are doing mostly mobile forensics, and for last 2 or 3 years, cloud forensics. Here is just one some of our customers, but I won't make the presentation commercial. Don't worry. Today we're going to talk about the iCloud keychain. First, about the iCloud in general, in case if you don't know what is that. About the two-factor authentication a little bit. And then about the iCloud keychain, how it is implemented internally, and what are the risks of storing your information in the iCloud keychain. How many of you are using iCloud keychain? No one, really? Okay, good. How many of you use the iPhone? It's probably less than Android ones. And nobody is using iCloud keychain, really. It's extremely convenient feature, but I will tell a little bit about it later. Let's start with the smartphone contents first. I'm actually using the smartphone much more than the computer nowadays, even at home. Even though I have a notebook, I have a desktop computer, but I do maybe 2/3 of my work from the smartphone. Everything is in there. My corporate mail, my personal mail, all my passwords, accounts to social networks, pictures and videos, and so on. I also use the iPad. They're of course connected to the same Apple iCloud account. Everything is synced between them. If needed, I can log on from the iPad to my office computer, which is running Windows. That I don't like at home. I use only Mac. And so the smartphone is actually an essential storage of all personal, private, and corporate information. There's quite a lot of data is there, including, for example, the geolocation history. Even if you disable almost everything, on Apple it's a little bit more safe than on Android. On Android, if you disable the location tracking, still some data will be there. On Apple it is better, but not much of the people disable that because you want, for example, geolocation tag on your pictures, just to save the history. What are the, speaking of forensics and how to get access of the data stored on the smartphone, there's quite a lot of methods exist. That's not only about Apple, they work for other platforms as well for Android phones. The most comprehensive method is JTAG or chip-off. Anybody of you is aware what is that? That's actually reading the memory chip from the smartphone. That's a destructive method. Chip-off, when you remove the chip from the smartphone, put it into the chip reader and extract all the data from that. Of course, the data might be encrypted. JTAG is a bit more safe. That's connecting to the special port on the phone. Not all the phones have that port. It's actually used for debugging mostly, but that way you can also get all the data from there. There is also a physical acquisition, which is hard and which is not available for latest iPhones, for example. There is a logical acquisition method, which is much more simple. Basically, it's just creating a backup of the iPhone. And now that is a cloud acquisition method, and it becomes more and more popular just because the physical acquisition doesn't work and logical acquisition doesn't provide all the information. The problems of cloud acquisition is that there are quite a lot of different platforms. The most popular are from Apple, Google, and Microsoft. That's not only about the Microsoft phones running on Windows 10 Mobile, but also about the Windows desktop systems. They're also syncing quite a lot of data between your computer and Microsoft Cloud. To get data from there, the major problem is that you have to have the credentials, login and password, and if the account is protected with this with two-factor authentication, you have to have the second factor as well, which can be a smartphone, the token, SMS, or something else. Speaking of cloud, there are several acquisition methods available as well. The cloud may be just a storage, like a Dropbox or Google Drive. There are also backups in the cloud, especially for the iPhones. For Android, the backups are not so comprehensive and don't contain all the data from the phone. And there is also a syncing method when the data is being synced across the cloud and all the devices connected to that cloud. And the data available from all those methods is actually different, the set of data, I mean. The full device backups, as I said, are available only for Apple, and only if you enable the cloud backup, which some of the people don't do, especially the paranoid ones. Most of the data is there, but many of the applications opt out backing up their data into the cloud. And cloud backups of the iPhone, they also contain the Keychain. The Keychain is the most secure storage in the iOS operating systems because it contains the most critical data, such as tokens, encryption keys, passwords, and so on, even the credit cards. And in cloud backups, this data is encrypted using the hardware-specific key. So if you restore from the cloud backup of Apple iPhone to the other device, all those data stored in the keychain will not be restored. Only part of it, actually, maybe the names of the records and so on, but you won't get your passwords back. There is no standard way to get the backup out from the cloud. Apple simply doesn't offer such option, so we have to use the third-party software to download backups. We have introduced such software, I think, 3 or 4 years ago. And do you remember the Celebgate, the leak of celebrity photos about 3 years ago? You know, at that time, about 100 of iCloud accounts of celebrities has been hacked through the iCloud backups, and the photos stored there has been published then on some forums and so on. Only after that, Apple enabled the two-factor authentication protection to iCloud backups. Before that, iCloud backups were accessible using just iCloud, Apple ID and password. Speaking of synced data on Apple, there is a bit less information than for Google Android devices. Google Android basically sync almost everything. There is also a backup, but once you restore the Android device and connect it to the same Google account, information is like synced back. Speaking of Apple, there is much less, but still there is quite a lot of interesting information, especially for forensics when investigating the crime or whatever. There is a call log, for example. Apple actually never published that information and never told us that call logs are being synced. We have found that when exploring the data stored in the iCloud. And there is no option on your phone to disable syncing of call logs. There are also media files. If you enable the iCloud photo library, there is a health data, surprisingly, which I think shouldn't be stored in the cloud because it's critical. There is also mail, but one which is cloud-based. There are also all your internet activities. They're also synced. Apart from, I think only the search history from Safari is not being synced, but the history itself is. There is also some other data like Apple Pay. Don't worry, your credit card data is not stored. If you use Apple Pay, only last 4 digits, and that's it. Home devices that use the home kit. The wallet data. Wallet is a storage for boarding passes, tickets, hotel reservations, and so on. So there is quite a lot. There is also information that it's not so easily accessible. If you go to Apple website and check the document about the law enforcement, what information Apple can provide by legal requests, you'll find a full list, what do they provide, and that includes, for example, all of the history of your purchases, of music, applications, and so on. There are also mail logs and logs of iMessage and FaceTime. There are no communications themselves, no chats, but there are still some logs, for example, when you connected and sent something. And there is some of deleted data. About half a year ago, we have discovered that the files in iCloud photo library are not being deleted even after 30 days and stored actually forever. Apple didn't officially respond it, but in just a few days after we have discovered that and released the software to download deleted files, they closed the hole, and now media files are stored only about 2 weeks. There is also available the list of all your devices connected to the account. You can do that right from your smartphone or your iPad, and the details about every device, including the serial number and so on. Now let's talk about the keychain. The keychain is something unique. There is no such thing in Windows operating system. Maybe the closest analogy is Windows registry, but the keychain is more interesting. It contains, yes, the most critical information, the passwords, encryption keys, and so on. There are 3 types of the keychain, which are very close by the structure and by encryption. The one is on the iOS device. The second is in the macOS operating system, and also the iCloud keychain. And all those 3 are connected and might be synced across their devices. On the iOS device, there is no way to look what is inside the keychain. The only thing you can do, you can create a local backup in iTunes. That backup should be created with a password. Otherwise, the data in the keychain is encrypted using the hardware key. But if it is encrypted with a user-supplied password, you can decrypt the keychain and decrypt actually some of the records from the keychain, not all of them. Many applications use the other security class that doesn't allow the items from the keychain to be decrypted. Speaking of macOS, it is simpler to browse. You can click on any item in the keychain and check the box to view, supply the logon password, and see the contents of that keychain item. For iCloud keychain, there is absolutely no way to view it until you sync your macOS computer with the keychain, and that way you can browse the iCloud keychain items that are being synced and downloaded to Mac computer, but exactly the same way, one by one records. If we compare the contents of the keychain stored in local backup in iCloud, you will find that they're actually very close. In the documentation on the iCloud keychain on Apple website, it says that only some of the passwords are being stored there, like Wi-Fi passwords, passwords to mail accounts, passwords to websites, and something else. But it doesn't say anything about the encryption keys, about tokens, and so on. And the other thing that is not saved in the iCloud keychain is the autocomplete text. Here is how the keychain looks like if you export it into the XML file. The first example is for the password to Wi-Fi access point. Here is the password to IMAP mail account, and here is the password to Gmail account. And there is not only the record name, the account name, and the password, but also the date and time when this record has been created and when it has been updated. This is also critical for forensics, actually. There is also credit card data stored in the keychain, also about the same way. There is card holder name, the card number, the expiration date, and just not the CVV code, sorry. There are different protection classes of the keychain, and they just define basically how secure that record is. Some of the keychain items are available, for example, after the not just right after the device is booted and turned on, but after it is unlocked with the passcode. And also there is a flag in the keychain property that indicates how it should be encrypted, with a hardware key or with a password, and should it be synced to the iCloud or not. To break into records in the local keychain, you have to break the password itself on the backup itself. It was relatively easy in older versions of iOS, up to iOS 10. In iOS 10, 10.0 to 0.1 exactly, it was actually an epic fail from Apple. They that was the same hash stored in the iCloud backup, which is relatively secure, with 10,000 iterations of SHA-1. But they also stored the other hash that was just single SHA-256, and it was extremely fast to break, millions of passwords per second, even on the CPU, not speaking of the GPU. They learned the lesson from our report and from release of our software. In next version, in 10.1, they removed that weak hash, and in version 10.2 of iOS, they extremely hardened the hashing, and now the speed of password cracking on the CPU is only about 5 or 6 passwords per minute, not per second. And on the GPU, on the fastest one available, we can only get about 100 passwords per second, which is also not much. That means that the passwords to iTunes backups are extremely hard to break. I would say not possible to break at all. Even if you have a supercomputer, you can break only about maybe 4 or 5 characters until, of course, you use a very simple password. Here is the macOS keychain I told you about. You can see that there are all the passwords, all the items together under the login, and just a little bit lower there is an iCloud. Actually, they can be viewed all together, or you can view only the cloud keychain items, of course, after they have been synced with the local computer. Speaking of iCloud protection in general, it is pretty good. There is a document on the Apple website describing what algorithms are being used, and the algorithms are strong. The key length is 128 or 256. Also, once someone accesses your iCloud account, you receive the notification on your mail. And after a few unsuccessful attempts, trying, for example, to break the password to your iCloud account, then the account will be locked. By the way, that's probably not a very good idea, because if you know someone else Apple ID, you can just try to log on to that Apple ID with a few incorrect passwords, and his account will be locked, and he will be out of syncing. After Celebgate 3 years ago, Apple also protected the iCloud backups with two-factor authentication. Actually, at that time, it was two-step verification, which is older and which is not so secure because it mostly uses SMS, and SMS can be intercepted or hacked, or there are some ways to break into them. With a newer two-factor authentication, it's now much stronger. The only way to break into account with two-factor authentication enabled, of course, if you don't have the second factor, such as device or SMS code, is to steal the authentication token from the computer, Mac or Windows, that is logged on into the same iCloud account. And using that token, you can access all the data in the iCloud, well, except the iCloud keychain. And there will be no notification and no need for second factor. Now, when you log on to the account protected with 2FA, you'll get immediately the notification on all of your connected devices, and you'll even get the map with a point from where the account is trying to be accessed. Speaking of the iCloud keychain, again, it keeps and syncs quite a lot of passwords to websites, to mail accounts, to Wi-Fi. It also stores the credit cards, and the technical implementation of that, it will actually blow your mind. It's really hard and multi-layer, but basically how it works, there is a special storage in the iCloud that keeps all that iCloud passwords. They're of course encrypted, and they're being exchanged across the devices. One device is logged into iCloud. It sends a notification message to the cloud, asking to provide with the new items, or if you add a new item to the local keychain, for example, accessing the password-protected website, that item in just 5 to 10 minutes is being uploaded to the cloud keychain as well. And all other devices connected to the account will get that password as well. To set up iCloud keychain on the account without two-factor authentication, there will be an option shown speaking the approve with security code. It's not from the first look. It's not really obvious what is that and how it actually protects an account. By default, Apple offers to set the security code the same as the passcode on the device itself. But there are also options available. You can use the random security code generated by Apple. You can create a strong security code, or you can not create the security code at all. And there is an important thing about creating the security code. I will show you why. With two-factor authentication, it is much more simple. Once the two-factor authentication is enabled, there is basically almost nothing else to do. There is no security code. You'll just get the device approved with a SMS sent to the trusted phone number, and that's it. But there is one more thing. Once the new device is enrolled into the iCloud keychain, you will be asked for the passcode of one of other devices that are already connected to the same iCloud account and the iCloud keychain. That looks weird. For example, I have the iPhone. I made a setup for the iCloud keychain there, and then I'm trying to do the same on the MacBook, for example, and MacBook asks for the passcode of my phone. That looks strange, but I will show what it is for. Now, I think starting from iOS 11, because I never seen that in iOS 10. Once you connect the device to the account without two-factor authentication, you will always get the red mark there. It looks like it almost exactly as the like when update of the iOS system is available, and it is reminding you to set up the two-factor authentication. That's actually a good idea. For the iCloud keychain, there are two modes to work with. There is a sync mode and there is a recovery mode. Synced mode, I already told a little bit about it. It is about the exchanging the passwords and credit card numbers and everything else across the devices and between the devices and the cloud. And there is also the recovery mode. What it is for? It is for in case if you have lost, for example, access to all your trusted devices. But still, you want to get your passwords back. This method works seriously differently. Deep inside, there are different protocols, different encryption, different keys, and everything else. You can get basic information on how it works from the security guide, which is for some reason is updated not immediately after the iOS release, but about a half a year later. And but it still describes that the basics of that about the keychain syncing. It describes that such thing like a circle of trust. You probably remember the term from the well-known movie. There is a public key for the syncing identity, and there is a private key which is impossible to break. It uses elliptical cryptography, and all synced items are encrypted specifically for the device. So, so the other device cannot get direct access to the item synced from the other device. For the keychain recovery, there is a special established escrow service in the iCloud. It is really secure, but it works slightly differently if you have the two-factor authentication enabled and if you don't have the two-factor authentication. Without the two-factor authentication, you probably remember I told you about the iCloud security code. It is really important. If you do set iCloud security code, anyone, then your iCloud keychain items will be stored and accessible by the escrow service. If you don't set the iCloud security code at all, then your keychain will not be saved in the iCloud. It will be synced directly across devices. To be honest, I'm not sure how it is implemented exactly technically, because that is out of our reach. We cannot go so deep inside into the Apple services. But still, there is no way to pull the items out of the iCloud if you don't have the iCloud security code set. So if you're paranoid and thinking about accessing your iCloud keychain items by the three-letter agencies, the most safe configuration seems to be without two-factor authentication, surprisingly, and without the iCloud security code. The bad side of that is if you lose access to your trusted device, for example, just broken your phone or forgot or got it stolen, you won't be able to get your iCloud keychain items back. Never. In the recovery mode, that's a basic diagram how it works. I'll explain it a little bit later. There is an escrow service. There are no much details on that. Oh, by the way, Apple also mentions that there is a special hardware security model somewhere in the iCloud. There is absolutely no explanation what is that. And it says that after 10 unsuccessful attempts of breaking into it, all the data is being securely wiped. Believe it or not, I don't know. Here is how it works. Are you aware of keyback term? I'm not sure. It's widely used by different, speaking of the keychain in general, not only the iCloud keychain, and it is also available in the local iTunes backups. The keybag is actually the storage where different encryption keys of any kind is stored. There is a keybag password which protects the access to the keybag itself, and the keybag itself contains the keys used to encrypt the items in the iCloud keychain. Here is the record of the iCloud keychain items. The first 4 bytes is the key version indicating the algorithm. The next 4 bytes is the protection class. I'll also tell about that. Then the size of the wrapped key, and then the data itself encrypted. So again, about the iCloud security code. I said that it is probably the most safe method to protect your keychain from anyone else. Don't set the security code. And there are 3 options available. You can set the simple code with just 4 or 6 digits. There can be complex security code that can contain any characters. And there is a next item is device generated or random security code. You will have to remember it, and it is virtually not possible to remember 24 random characters. You'll have to write it down. And another funny thing is that if you use the simple or complex security code, then in the iCloud, the hash of that security code is saved and being used. And if you use the device-generated security code, then that code itself is saved there. So Apple is probably thinking that it's secure enough. For every device that is enrolled into the iCloud keychain, the escrow proxy has the record that looks like com.apple.com.icdp and the device hash. That's a hash of the unique device ID. And the contents of that record is randomly generated backup back password. And it's used with the RFC algorithms to encrypt the keys from the keyback. The escrow proxy, as I said, that it's not documented how it works, but what we have discovered that it uses the secure remote password SRP protocol, which is much safer than general protocols used even for SSL connections. It is absolutely safe from man-in-the-middle attacks, in contrary with HTTPS. And it doesn't need the passwords to be transferred across the network, even the hash of the passwords. And it doesn't keep any critical information such as password itself on the service. So it is based on the access by tokens. The most interesting keychain, cloud keychain records stored in the escrow service are, that's a com Apple secure backup. It contains the backup back password, and it is being used for the full restore of the whole iCloud keychain. And there is also another types of records, com Apple ICDP with a device hash. I told you about that. It contains also the backup back password, but for individual records for given devices. And so that way, we can recover not the complete iCloud keychain, but the individual records of it. If you don't set the two-factor authentication, then the algorithms works basically as the client, I mean the device, generates the random 25 characters keyback key. Then it is the hash is generated with the 10,000 of SHA 256 from the either iCloud security code or the passcode of the device. There is no difference between them and from that point of view. Then it is encrypted with using the hash as the key, and that encrypted keyback key stored in the escrow proxy. There is a kind of API to work with the escrow proxy. It is used, of course, only internally by Apple itself to acquire the certificates, to add new secure records, to get the list of available records there, to get the phone number associated with the account, to send the verification code there, and some other things, to initialize, to recover, to get the data back, to update records when the password has been changed to some resource, and so on. There are also some public records which are more easily accessible without all that stuff with the encryption keys. Some device data, the number of failed attempts actually, so we can get that once we log on and try to add the device to the iCloud circle of trusted devices, and some other data. Another thing the iCloud Keychain is based on is SRP protocol version 6. To be honest, I don't have an idea how it is different from the previous version. That report is actually a result of the work of large team of our researchers, and so even me, after reading that, don't understand all the technical details deep inside. As I said, by analyzing the so-called public records in the iCloud Keychain, we can understand, for example, whether the iCloud security code is set or not, and if not, we are out of luck and we cannot get anything from the iCloud. And if that code is set, we can log on. Access to escrow proxy, which is used for syncing and for recovery, is based not on the password but on access token. And the token is actually different from one we widely use to access the iCloud backups. For example, when you log on to the iCloud from the Mac or Windows computer to get some of your data synced between the computer and the iCloud, the token is generated and saved locally, and we can extract it, decrypt, and use to access the iCloud backups or iCloud synced information. But that is not the token to access the iCloud backup. The token for iCloud Keychain is called password equivalent token, and it has a very short time to live for security reasons, only 5 minutes. And to get that token, we haven't reversed that algorithms till the end. The new type of authentication is being used, called GSA. In synced mode, everything looks a little bit simpler, but to work completely with sync mode, you have to add the trusted device to that circle. That's not so easy using the private API, but that will be immediately recognized by all other devices. You'll get the notification that some device is being added to the trusted circle, so it leaves the traces. But still, if you're able to do that, you'll get full access to the key value storage and all the items in the keychain. There are also such things as called tombs that are actually encrypted records of individual items that allows to work in a, say, mixed mode between sync and restore. The algorithm of encrypting the tombs is really also hard and multi-layer. You first get the list of the tombs available from the Apple servers. You find the record IDs, you get the backup password for every record ID. You have to unwrap the keyback key, decrypt the keys from the keyback, and only using that key get access to the encrypted keychain items. What are other important parts of the iCloud keychain? First, the GSA, as I said, the new authentication that it was started in macOS version 10.10, but only its basic implementation. In the macOS 10.11, it is seriously improved. There is also the thing called NEC data stored on the computer once you add the computer to the trusted circle, so it can access the iCloud keychain. And there is a continuation token. That is the most important key to all the data. And with that continuation token, which is actually hard to access and to decrypt, but it is theoretically possible from the computer, you'll be able to access the iCloud keychain and get all the items from it without any notifications, without need to know the Apple ID and password, and without the second factor. I think I have a little bit time. I will show a very quick demo how the iCloud keychain is accessed. I have to supply the Apple ID and password. I will use mine, our main account. It is protected with two-factor authentication, but I already accessed that account from that computer, so I won't have to pass it again. But let me see where the internet connection works. Yeah, it is. It will take just a few seconds to access. Internet connection seems to be slow. Okay, so here I can select the list of all trusted devices. That's all the devices connected to the same iCloud account that have or had the iCloud keychain enabled there. But even after removal of that device from the trusted circle, I still can use its passcode to access the iCloud keychain. So I'll select the, say, my iPad. Enter its passcode. I select where to download, and it will also take just a few seconds. Oh, incorrect passcode, sorry. Let's try again. There's another interesting thing about the incorrect attempts. After 5 incorrect attempts, your iCloud keychain, oh no, what the? It couldn't get wrong. I think it's actually a problem of the internet connection, but not the. Okay. Let's try with the other account, which doesn't have the two-factor authentication enabled, but have the iCloud security code set. Or maybe someone accessed my iCloud keychain already and changed the passcode. Oh no. Okay. When accessing the iCloud keychain for the account that doesn't have the two-factor authentication set, I will have to enter the iCloud security code first. Okay, then the second step is after I entered the security code, I should receive SMS from Apple with the SMS code. Yeah, I got it. Download, let's see. Okay, now it works. We go to Explore Backup, and we have different categories of data extracted from the iCloud keychain. First is the Apple IDs and passwords. I actually accessed quite a lot of different Apple ID accounts from my devices, from different purposes. For example, our corporate developers account on Apple, and so on. And the passwords to them are stored there. I have over 40 Wi-Fi network passwords. I have several mail accounts that include our corporate exchange account and my personal mail. There are passwords for websites, almost 400. There are 9 credit cards, some of them are expired. And probably the most interesting part is the tokens. You can see, you can recognize the tokens to social network accounts for Facebook, Twitter, LinkedIn, Adobe, and some other things. In the Apple Keychain documentation, there is nothing about that, actually. It only tells about the passwords, but not about the tokens. I'm really close to the end. Some conclusions and some risks. To access iCloud Keychain, you cannot use just the sync or recovery mode. The both also won't work well for accessing the data. So what we have used is a kind of mix of the synced and recovery modes. So that's like a recovery, but not for the whole keychain, but for individual records. You can, of course, use a pure sync, and there is also no API, but at least you basically know how to do that and how to add a new device and get the password synced there. But that leaves quite a lot of traces and notifications on the all connected accounts. To access the keychain, you need to have credentials, Apple ID and password. You need to have access to the trusted device or to receive the SMS code. If the account has no two-factor iCloud security code set, you cannot access it. If it does have the security code set, you have to know it. And also after that, you will also have to receive the codes sent by SMS. If you still have the old account with a legacy two-step verification on the account, it's not recommended to use it at all. It's not convenient, not safe, and probably not secure. It's now almost not supported by Apple, so I would recommend to change it to two-factor authentication. And if you are really paranoid and don't want your data to be even theoretically accessed by someone else, it's the most secure way is to have the account without two-factor authentication, and without the iCloud security code set. But that way, if your password will be leaked, someone will be able to access, for example, your iCloud backup. The only risk, and which is not explored yet, if someone gets a physical access to the Mac computer that is connected to the same iCloud account and has the iCloud keychain option turned on, and steal the continuation token from it. But that's extremely hard to get. We're working on that for several months, and we weren't able to do that yet. I'm sure we will, but we need some more time. And finally, the other conclusions. The iCloud keychain, remember that it contains not only the passwords, but also the authentication tokens. And if, for example, your other accounts for secure messengers, for social networks, and so on, are protected with two-factor authentication and you think you're safe, but if you will get your device stolen or lost, and someone will be able to break into your iCloud keychain. He'll be able to access all of your accounts. You will have to change all the passwords and enable two-factor authentication again. The other interesting thing is that the iCloud keychain, as we have found recently, just about a week ago, seemed to be created in the cloud right when you enable two-factor authentication. Even if you have no single device with the iCloud keychain enabled, still the iCloud keychain is there, but it contains only the special system keys, but no user passwords. And it also contains some new special keys that are used in iOS 11. I cannot disclose that information yet, and we're still exploring that. And probably the best way and the best advantage of that approach, accessing the iCloud keychain, is for the case when you cannot, for any reasons, get access to the local keychain. For example, when the device has the strong iTunes backup set, and you cannot perform the physical acquisition, and even if you manage to break the iTunes password, you will not get all the records from there. For example, some of secure messengers like Telegram, they do store the access tokens in the local keychain, but you won't be able to decrypt them from there. Only from the iCloud keychain you can. So that's it. Thank you.
再次谢谢他为我们精彩的演讲一下有关那个 Keychain 的怎样储存啊，跟它的原理，跟Apple 怎样是对这个 Keychain 做保护。然后如果你想要打造这个工具的话，他刚才已经很清楚告诉你说打造工具有哪些步骤需要先执行的。那如果你不想要打造工具的话，你可以尝试考虑一下用一下它的工具，应该是已经完成这些你上面遇到那些困难，它都先帮你解决掉了。好，那大家还有问题吗？好，那没问题的话，那大家再掌声感谢一次。